Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with chemistry. The topic is thermodynamics. This is lecture number 30. And in this lecture I will explain again about Carnot cycle. And in this lecture, this is the fourth lecture regarding Carnot cycle. We already discussed the 4 steps of Carnot cycle. Now the first step, in which the pressure is P1 when volume is V1. So this is the initial state of step 1. So this is step 1 where it is initial state and pressure is P1, volume is V1. From here the graph goes like this, that it will reach from first position to second position and comes over here. This is second position, it is position B or second position, and here the pressure is P2 and volume will be V2. This is V2. So it is second condition where pressure is P2, volume is V2, and the movement from first to second is like this. And here, in step 1, temperature remain constant T1, which is very high, and it is called isothermal expansion. So the first step is isothermal expansion, where it goes from first position to second position, where the pressure is P2, volume is V2. Okay, this is second part of this one. Then it goes to the third one. From here it will reach to this part, third one, where pressure is P3 and volume is V3. So this is volume V3, which is slightly greater than this. Pressure decreases and it is P3, sorry. Okay, so this is the third condition where it goes from second point to third point like this, and here this is step 2 where it is adiabatic expansion. Heat changes 0 and temperature changes from T1 to T2. Now temperature is T2 over here and it is adiabatic expansion, so temperature decreases, and here we go from second condition, second step to third step over here. Okay, from here we'll reach to fourth step, which is this one, where pressure is P4, volume is V4. Okay, and this is the way we move from third step to third point to fourth point. This is step 3 again, and here compression takes place, so it is called isothermal compression. And it is the fourth point again, where pressure is P4 and volume is V4, and from here we will reach to the first initial state over here, and this is fourth step where adiabatic compression takes place, because still volume decreases from V4 to V1 and pressure from P4 to P1, where pressure increases, volume decreases, and temperature will go. Here the temperature was T2 and now the temperature goes from T2 to T1. So this way temperature changes over here, and therefore finally we reach here. So graphically we can explain the whole Carnot cycle in this 4 step. Okay. Now we will see net heat absorbed during this process, Carnot cycle, the net heat absorbed during the Carnot cycle. So net heat absorbed is Q, and Q is equal to Q1 plus minus Q2 because Q2 is negative. So Q1 is, you know that we have already derived the formula 2.303 RT1 log volume changes from V2 to V1, and plus for minus Q2 we write 2.303 RT2 log V4 to V3. Since V4 is less than V3, so we can change the sign of this, and that is why we write 2.303 RT1 log V2 upon V1 minus 2.303 RT2 log. Now we can reverse this, so V3 upon V4. So here we can put negative sign. So according to the expression governing adiabatic changes, right, T1 upon T2 is equal to V3 upon V2 raised to gamma raised to minus 1. This is for adiabatic expansion, and T2 upon T1 is equal to V1 upon V4 gamma raised to minus 1 for adiabatic compression. Now V3 upon V2 is equal to V4 upon V1. Therefore, V2 upon V1 is equal to V3 upon V4. So we can substitute these relations in above equation. So now we can write for total heat absorbed, Q is equal to Q1 minus Q2 is equal to 2.303 RT1 log V2 upon V1 minus 2.303 RT2 log V2 upon V1. Instead of V3 upon V1, we can put V2 upon V1. Therefore, Q is equal to 2.303 R bracket T1 minus T2 log V2 upon V1. So this is the net heat absorbed during this process. Okay. Now we will see net work done during this process, cyclic process of Carnot cycle. So we write now net work done by the gas, that is W is equal to W1 which was negative minus W2 negative plus W3 positive plus W4 positive. So we write is equal to 2.303 RT1 log V2 upon V1 minus CV into T1 minus T2 plus 2.303 RT2 log V4 upon V3 plus CV into T1 minus T2. for W4. So here we can say this is negative, this is positive, so both will be cancelled. So W is equal to W is equal to 2.303 RT1 log V2 upon V1 plus 2.303 RT2 log V4 upon V3. Since V2 upon V1 is equal to V3 upon V4, therefore we can write here that W is equal to 2.303 R bracket T1 minus T2 log V2 upon V1. So here you can see Q is equal to W. So thus we can say that Q is equal to W, and this is for cyclic process. So we write that for cyclic process, the essential condition is that net work done is equal to heat absorbed. So this is regarding Carnot cycle. Okay, that's it. Thank you so much.